My name is Sarah Pekowski, and on behalf of my team, I'll be presenting the paper Optimizing and Evaluating Enterprise Retrieval-Augmented Generation, a Content Design Perspective. I'm going to quickly review what Retrieval-Augmented Generation is. I'll clarify what I mean by content and content design. Then I'll touch on three aspects of our paper. Retrieval-Augmented Generation, or RAG for short, is a popular method for using large language models that can help ensure that the output is more accurate and less likely to be a hallucination. You can use RAG for different kinds of use cases, but in this presentation, I'm going to focus on the question answering use case. When a question comes in, the first thing you do is search a knowledge base for relevant content. In our case, our knowledge base is product documentation, and the content that's in there are individual articles. Once we find articles that are relevant to the given question, then we create a prompt like this. We paste in the content of those articles, then we instruct the large language model to answer the given question, and then we paste the question into the prompt. When we send that to the large language model, the output that gets generated will be an answer to the given question based on the information in the article. In this presentation, when I talk about content, I'm going to be talking about things like the text that you see in the hover help of graphical user interfaces, tutorial videos that you might watch to learn about software, the text strings that you see on a command line interface, and product documentation. You might not realize that content design teams that produce this content have pretty elaborate processes and tools. So for example, we have a content strategist that will decide how the information gets broken up, and we have pretty specific writing style guidelines to make sure that even when there's lots of writers working together, the content that they are all producing has the same tone and writing style and is consistent. So for example, if I was trying to decide whether I wanted to use the phrase dataset as 2 words, dataset, or just 1 word, dataset, we actually have a terminology database that I would go look it up and make sure that I'm using the term that we've decided we're going to use in our content. We also spend a lot of time testing to make sure that people who are using tools like screen readers can easily navigate and consume our content. And we spend a lot of time making sure that we're setting translation up for success. So we know that our content is going to be translated, whether it's translated by humans doing the translation or whether it's machine translation. There are ways that you can write your content to set that up for success. One thing you should understand is that content designers are word nerds. We're pretty into writing. And so, for example, a little while ago, this article was shared in our team Slack channel. You can see here that the modifier on holiday in Thailand is supposed to apply to Lindsay Lohan, but it's closer to the word snake. And so the way this is written is ambiguous. And so everybody had a good laugh and say, ha ha, hope that snake had a good time on holiday. So when large language models burst onto the scene a couple of years ago, content folks were really excited because we could see that large language models are a content technology. It's right in the name. Language is our whole thing. So how would a content person go about building a RAG solution? Here's an example of an early RAG solution. It's actually the search page for product documentation. At the top you can see the search bar and there's the search results below it, just like normal. But what's new here is that when the query is phrased as a question, then on the right hand side a short answer is generated by a large language model and given to the user along with a link to the article or articles in which that answer is grounded. We made a couple of tactical choices here. So for example, by reusing the search page, we set things up so that users didn't have to go and learn a new interface. They were already accustomed to going to the search bar when they were looking for information, so we just reused that search bar for this RAG solution. Also, the search bar is only one line and it's not very long, and so that nudges users into keeping their questions concise. Now let's look at the architecture under the covers. When the user input comes in with some components and microservices set up to filter out malicious input, to remove personally identifiable information, and to mask or remove or paraphrase hate, abuse, and profanity, and also to translate the input into English. Then we classify the input. Is it a question or is it not a question? And if it is a question, what kind of question is it? Is it a what is question or how to question? Is it troubleshooting kind of question? And that's because we might want to use a different prompt for the different kinds of questions. For example, a how to question should have an answer that is in the form of an ordered list of steps. So once we've done that, now we have a question in English to move forward through the solution. Next, we double check to see whether this question has been asked before. And if it has been asked before, was an answer generated that has been evaluated as a good answer? And also, has the article in which the answer is grounded been updated since that answer was generated? Because if the article's been updated, maybe the answer would be different now. If the article has not been updated, then we would go ahead and just return the previously generated answer. But if it's a novel question, then we go through the RAG pattern. First, we set search up for success by adding some synonyms and rewriting the query a little bit if necessary. And then we go ahead and search in our documentation. Here I want to say that not all of our RAG solutions use vector databases. I think there's kind of an assumption. A lot of people who want to build a RAG solution, they see that vector databases are popular, so they assume that they have to do that. But we haven't found that we need vector databases, and sometimes the vector databases don't even perform as well as some of the more traditional search methods. And that's because of the way our content is structured. I'll talk about that in a little bit more detail in a minute. I just want to emphasize here that search doesn't necessarily mean vector database. Once we find the relevant articles, we extract the entire article to put into our prompt. Again, there's a kind of an assumption that when people are building RAG solutions, you're going to chunk your content into pieces. And the reason we might not always need to do that is, again, because of the way our content is structured. And I'll get into details about that in a second. So we pull out the whole article or articles, and then we create the kind of prompt that was on the previous slide, and we send that off to a large language model. So because we've done all of this work, filtering out the problems, translating English to English, once we get to the point where we're prompting the large language model has only one job, and that is to pull out the correct information from the article and phrase the output as an answer to the given question. That's it. We don't need a big fancy model that can handle all kinds of different natural languages, or that can solve logic problems, or that can do multi-hop reasoning. This keeps the job of the large language model straightforward. And that means we can use a smaller, faster, cheaper, open source model to get the job done. I know that there's a lot of academic interest in the bigger models that can do logic puzzles and stuff like that. But speaking as somebody that's been building AI solutions for a long time, just the fact that you can generate a dynamic answer based on the article, that is already game-changing compared to trying to maintain chatbots that have a dialogue with hard-coded answers. Once we get the output generated, we send that back through our same components to filter out problems, and we translate the answer back into the user's original language. And then we add links to the articles in which the answer is grounded. Then we collect some logging, and we send the question that gets asked and the answer that gets generated and some diagnostic details to a Slack channel in real time so that our team can see what questions are being asked and the answers that are being generated in real time. Because there's the chance that a large language models can generate bad output, we feel that this kind of proactive real-time monitoring is necessary. We also send diagnostic information to an evaluation tool, which I'll talk about in a second. A couple of times now I've talked about how our content is structured. When we're writing our product documentation, we use something called topic-based writing. That means whether we're describing a concept or explaining how to perform a task, the article or the topic is self-contained. It has all the information in there that's relevant to that one idea. It doesn't go off in 10 tangents. And also it's written in a way that's concise to get the job done. And also it's already optimized for search, and the title that's selected for the article is optimized for search. And so we're kind of used to that before now anyway, like before RAG even existed. And we have all kinds of detailed writing style guidelines that help to make sure that our content is not only concise, but also clear and unambiguous. So for example, if I was to put in a topic, you may install feature X. Does that mean you're allowed to install feature X? You have permission to install feature X? Or does it mean you might install feature X? Our content was already following these kinds of guidelines anyway. And we noticed when we started building RAG solutions that when we were getting poor answers because the article was unclear, we could improve the answer that was generated, not by changing the RAG solution in any way, but by improving the way the article was written. And the reason I'm pointing this out is because when we were doing our literature search, when we started working on our projects and we were writing this paper, we found all kinds of examples in the literature of ways to improve RAG solution results by maybe fine-tuning the embedding model or using a different vector database or changing the architecture of the large language model itself. But nobody was talking about systematically optimizing the content in the knowledge base itself, which was weird to us because as writers, that was our first question. How should we be writing content to make our RAG solutions more successful? And I guess that speaks to the importance of having teams from different backgrounds and with different perspectives coming in and being a part of this conversation. We created an evaluation tool that we use to review and evaluate the answers that our RAG solution is generating. So we can go in there once a week or every other week, and we can see the question that the user is asking, we can see the answer that was generated by the solution, and then we have some evaluation criteria that we can quickly just check off. So for example, is this a question we should be able to answer? And if so, do we have an article that can answer this question? And if so, did search find it? And then when we put it all together and sent it off to the large language model, was the large language model able to generate a good answer based on the given article? And we can just do that fairly quickly. There's some features of the tool to streamline the task, and there's some automation in there to make things go faster. A lot of times people see this and they think, oh no, a manual evaluation sounds like a lot of work. Can't we just automatically do that evaluation? Despite the fact that we are using some automation in our tool, I would argue that you still are going to need some human oversight for monitoring and evaluating your RAG solutions. There have been a variety of methods for automatically evaluating RAG answers. You can see some here, and these have a place. Like, we do actually use some of these. But I would argue you cannot fully rely on these. For example, one of the methods for evaluating whether an answer is a good answer is looking at whether the answer is faithful to the article in which the prompt is grounded. And that's fair, but what if the article's wrong? I know that in our case, our documentation topics get updated a couple times a week sometimes. And so even if the answer is faithful to the article, if the article's wrong, then the answer is still not going to be good. Also, what if it was faithful to the article, but it was faithful to the wrong part of the article? Then the answer is still going to be wrong. I've seen teams who are hoping that they can deploy their RAG solution and then they'll just put like thumbs up, thumbs down kind of thing, and they hope that users will just give them feedback and that'll be good enough. But in my experience with customer support kind of chatbots and solutions like that, I have seen that customers just, they don't. they don't want to be your quality assurance team. So relying only on your external users to give you feedback is risky. And I would also point out that if you're doing regression testing, so if you save the answers that were generated and then you make changes to your RAG solution and you want to run the same questions through again to make sure you haven't broken your RAG solution, there are methods that you see with RAG benchmarks, Rouge, Blue, BERT score, that kind of thing, using a large language model as a judge. These strategies are pretty good, but I would argue again that you still need a human to double check. So for example, when there's a couple different ways to word an answer, then this automatic matching of the runtime answer with the expected answer isn't going to work. Or if there's more than one right answer, that also isn't going to work. So I'm not saying you cannot streamline your work with some automation, but I'm arguing you can't fully rely on automation only. The reason this really matters is because the stakes are so high. Before, when users would just search for information, if they didn't get back anything that looked good, they would just search again. No big deal. But now that you have chatbots that are returning authoritative sounding answers that are, like in a complete sentence and looks very compelling, people are just taking that information and believing it. And then if it turns out that information is wrong, they're getting into a lot of trouble. Air Canada, for example, had a chatbot on their website or whatever, and a customer got some information from that chatbot, turned out to be wrong, and that customer sued Air Canada. And then in the lawsuit, Air Canada kind of said, hey, what are you going to do? Sometimes chatbots just say the wrong thing. But the judge wasn't having it, and Air Canada had to pay the customer. So the stakes are much higher now. You need to make sure that your solutions really are returning the right answers. And that's why I would argue you still need humans to be monitoring and evaluating these results, and you cannot rely fully on automation. That's it for this presentation. Check out our GitHub repo. We've got sample code there, and we have a deep dive discussion into topics like processing tables and links to blogs. Just for fun, here are 2 more examples of misplaced modifiers making things ambiguous. I hope you enjoyed this presentation.